Hey, everybody. Fascinating chat today with an industry leader with a long and storied history at STMicroelectronics. Marc, how are you?
I'm very good. Thank you, Ivan.
Well, thanks for being here. Really excited for this chat on how AI is changing the semiconductor industry in many ways. Before that, maybe some introductions to yourself and also the long and storied history at STMicroelectronics. Maybe give an overview for the viewers here.
Well, ST Microelectronics is an industry leader into this silicon industry, semiconductor. It's a company with roots in France and Italy, coming back all the time to Thomson and SGS when they merged and became one of the industry leader. We are among the largest company in terms of MCU and we serve many industries, like especially industry, CPG, and of course on the consumer goods, of course, and automotive especially. So that's what we do. As for me, I lead for ST what we call AI solution. That's a division we founded in 2021 when we brought together a number of artificial intelligence project initiative we had. And that's actually when I joined ST, because I was a founder of an AI startup named Cartesium that was acquired by ST in July 21. And Cartesium was one of the leader of AutoML for embedded AI, very, very small algorithm for predictive maintenance, this kind of capabilities. So my team came over, we grouped together a number of initiatives, and we founded AI solution. And that's basically how I became part of ST. And before that, I had a long time in the industry, working a lot on AI, especially with IBM before founding Cartesium.
Wow, really fascinating story. Really thrilled to have you here. Let's talk about change and disruption. AI, as you know, is changing everything, but particularly in the semico industry, we see the headlines every day. But from your point of view, walk us through the different types of AI, especially at the edge where all the excitement is and why it's become so critically important to the industry.
Yeah, so first, I'm really glad to see all the planets finally aligning. It's something that my colleagues and I, when we founded Cartesium all the way back into 2016, were very convinced of. And at the time, the driver for us was a number of projects we were conducting into whatever previous life we all had. I share mine, but some of my colleagues had different life as well. And into that, we became convinced that AI will come into many different places, into what we call everyday's life. But we also became convinced that one of the key inhibitor for that would be the cost. It would become something that people will be using if the cost of using it would be affordable and be something that someone would accept to pay. It's something to say, would I like to speak with my refrigerator and interact and get information about what to order? But the point is, how much are you ready to pay for that? And so can I do a solution that runs? Yes. But can I do it at a price that people will be willing to pay? Well, maybe not. So it's actually why we had this vision to say, in order to make it affordable, we have to move the ability to infer very close to the device, so that the cost will be way less than having to carry the cost of the cloud. What we didn't know at the time was, and it's becoming very true now, is with all the explosion of the AI project, you just simply could not provide inference for all the devices that are about to come on the planet into a cloud. Simply, the global power grid is not big enough for that. So you have to find a better way to do it, so that it's power effective and will actually not stress the system, the electric system, in a way that will make it impossible to happen, which is all the driver for embedded AI.
Yeah, very exciting. And many analysts are predicting the semiconductor market could double by 2030. That'd be extraordinary growth. What's behind a lot of that? What, are there certain industries, use cases? Obviously, AI is pushing the boundaries. What say you?
Yeah, it's something I have a lot of passion for, and it's and the way I observe it, I had a chance to have like literally one of the front chair into this for the last 6 7 years. It's people are starting to realize that they could actually build AI into their product,
Mm,
and it and the way we like speaking about it is when you make a product. Let's take whatever product you want: coffee maker, pumps, power drill. It doesn't matter. For many years, the ability for the product to be seen as a great product was just defined by how well you were pumping, making coffee, or drilling. It was really your ability to make a good product. But now, what's happening is you can just enter into a new dimension just by adding new features that will be using AI. So if that's a pump, that the ability to not only pump, but predict when your pump will stop or is blocked by something before it stops, because when it stops, it's a real problem. And you cannot do it. If that's a coffee machine, that's the ability to adapt the level of heat, for example, in the system or water, based on the capsule we'll be putting into it. Also detecting whether it's a time to clean the machine or not. If you do a power drill, that will be the ability to literally stop your drill before it goes into a pipe in your wall and you end up with a disaster because you have water everywhere. So all
mm,
that is AI defined. And great product in the future, in the 5 star, will all have AI. And if you do not have AI, then you just don't exist. So now what is the problem? The problem is when you meet with the product manager of any one of these companies, they just don't know what AI can do for them. These guys know everything about coffee machine, about pumps, about power
mm.
drills. They know nothing about AI. And especially for I would say the previous generation. And so we spend a lot of time engaging with them on what we call ideation, which is explain to them what AI is, because we have to start by what I call demystifying AI, because people from AI like to look really smart, and they like to make all the people who are not from AI feel dumb because they are not AI expert. And we are doing the exact other way around. We're saying, no, 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 hold on. AI is just another form of IT. It's just another way of doing it. So let's discuss about it. Let's explain to you what is a traditional machine learning system, what is a random tree, what is a neural network, what kind of neural network, how you do it, and then let's discuss the way we could apply this to your product. And then we go into this brainstorming session of what could make a product great, what really bold idea we could have that really would be funny but silly, and then as this we like building a prototype with clients that they like of what their future product will be. So that's one thing. So there are two drivers of this change. The first one is a new generation of product manager are finally understanding what AI could do with them beyond just speaking to their refrigerator. So something I would say more in line with the value of the product. The second thing that is happening is models and hardware are becoming effective at that. Because for many years, models were designed for large systems, NVIDIA or these kind of things, and therefore the kind of edge devices were very expensive. Now, if I can, into my product, instead of having something that will cost $100, cost $5 or $2 or $1, then it makes sense. Then you can finally afford it, and which doesn't need to go into a cloud, and then you don't need to pay whatever amount of cloud or storage data per month. Then you can afford it. So the two things aligning are the fact that product manager into all our clients' company are understanding what AI can do for them, and on the other side, the fact that now you have AI accelerated capabilities into very small, less than $5 chips, and models that are optimized with compression, with quantization to run this on these very small chips. So you bring the two together, it's a perfect storm. It's a time where you see AI exploding and it's driving the growth you were talking about.
Wow, brilliant observation. That's incredible. And we're also seeing edge devices everywhere. I mean, everything is an edge device now. Your smart kitchen, as you kind of referenced, a train, your smart car, airplanes. our edge computing devices. I mean, what does this mean for the semiconductor industry and the way they've traditionally designed, delivered devices and solutions?
Well, it's so it's it's interesting because I think it's changing a lot the way we engage with our clients. It's so first you see the explosion of devices. Into these devices, you bring more and more micro MCUs or NPUs, mostly MCUs, relatively inexpensive one, and they become able to do tasks that were not done before. So you had a
Mm.
lot of them. You take whatever, you take, well, arguably my bicycle from 10 years ago had zero MCU into it, of course. Then you replace it by an e-bike and you start having a number of MCUs or semiconductors that you start to put into it, for your ability to direct it, for your battery management and so on. The more you think about it, the more you add of these capabilities. But what is interesting as well is there is a limit into it which is financially defined. So you cannot simply add more and more features and expect that the customer, the end user clients, the clients of your clients will follow up whatever the price will be. Same for the cars. If you think about your car, it can do many, many more things than the car you would buy 10 years ago would be doing, from reading the road signs to being able to understand if you're moving off the line, to being able to detect your attention, whether you are tired or not from your eye, and being able to tell you it's time to make a stop, to all that. They are AI powered features. And it's all running on MCUs. But at the same time, your price has to remain about at the same level in constant price compared to the salary of someone. So you
Mm.
have to add all these features by not adding a lot to the price. So it's a challenge we have. So there is a big opportunity because we'll add more and more. There is a shift from a number of other parts to electronics, and this shift is going to people able to provide it and provide these MCUs and NPUs capabilities and sensors at a price that will be affordable with the level of features the clients will be able to do. So it's what's making it. And for us, it's why we like to speak about a stack, because a lot of that is hardware and a lot of that is software. Because on top of your hardware, you start adding a stack of software that will take the models, optimize them, and run them on a very small footprint. And this is why we have this strong focus on software. If you remember to what I did when I introduced myself, I'm not coming from the hardware industry. I'm coming
Mm.
from I am into the hardware industry, but I'm coming from the software industry. So the hardware vendors, the hardware chip vendors are becoming software people. And my team was acquired, and we made a number of acquisitions into the software space just to add to the stack of optimizing the algorithm that the client will be running on the hardware.
Brilliant. Um, you referenced about, data centers powering AI using a lot of energy. We're potentially facing a kind of a brick wall when it comes to AI and energy usage. What does the industry need to do to make this vision more sustainable, realizable, more cost effective?
Well, it's a chat I have all the time with our clients. It's when you design your future product, you have two schools of thought. The first one is you just ignore it and expect that nothing will happen and hope that people will keep building dams next to or data center next to dams, and like some big companies are making, and that everything will be fine in the future. And people will start to say, well, we have to change the way we do it. And we are very much of the belief that it's a second way. One example that we like talking about, which and without going into too many details, it's something I started to work before we founded Cartesia. And it was a project with a very large city in the US. And the goal was to have the CCTV cameras analyzing their stream and being able to detect if someone had left a bag, and if a bag was here, understand it with AI, and then dispatch a police car to secure the
Mm.
perimeter. And so that's really the story. So there is literally no difficulty from an AI standpoint at doing it. It's very, very simple. It's literally, I would say, a second year assignment for a student in a machine learning class. The point is not there. The point is, if you have a city with 16,000 video cameras, you want to stream this kind of data, which is petabytes of data, and you want to analyze it real life, the cost to the city is in hundreds of millions of dollars.
Wow.
So now the vision is, okay, that is a lot of impact. The second thing is the cost of running all that is from an electricity standpoint is huge. So now if you say, well, instead of streaming all this data, I will have my camera smart enough so that it can understand it, detect the information, and send it. You actually don't use any watt incremental. You just run it there, you stream, but then you don't compute anything on the cloud. You only compute in the cloud if something which is not normal has been identified for the second level of AI. Then when you do this, if you have 16,000 cameras, the level of electricity, of power that you save is the equivalent in a city like New York of removing all the yellow caps from the city of New York from a gas standpoint. It's unbelievable. And the saving to the city is the equivalent of hiring 8,000 more police officers. So now you start to see the dynamics of it. It's unbelievable dynamics. It's industry changing. And when you say this to people, they say, no, this cannot be true. Then they check and they say, wow, that's actually more than that. So and so we iterated this and we do this in a number of industries. So it's the power of what we're about to observe. I believe a lot into it. To me, it's something as powerful as what happened with LLMs and OpenAI, in the field of being able to interact with a computer. It's a different field, but it's one which is very powerful and game-changing and life-changing for people as well, for everyday device.
A great anecdote. The semiconductor industry loves big breakthroughs, and following Moore's law over the decades. Revolutionary advancements in power and energy and size and performance. And what looking forward, what are the big chip design breakthroughs that you think make the biggest difference, in the everyday applications that you kind of described?
Yeah, I can share the bet that we made and why I'm feeling really very, very good about it. And I can share even more because that's a decision that ST made before I came on board. So it's I won't take the credit for that. The other people deserve the credit. The vision was that if you start to believe into the story I'm telling you, then what happens is that you will need AI acceleration into your chip. So what we call NPU, neural processing unit. So it's the equivalent of a GPU, but simply it's on a very small footprint, which will be less than 1 millimeter square most of the time, probably half a square millimeter. So, to give you an idea, and we'll be able to provide a level of performance in TOPS. So that's and that's the way we think of that. We think in terms of TOPS per square millimeter. And we are going into a very, very small. So think of thing which is less than 1 millimeter square, and then maybe say, okay, what if I can run one top into this? Not even quantize. So it's so that is really powerful. So when the people at ST started to think about it, their view was that there was no technology available in the industry that would deliver the level of TOPS per square millimeter and the level of TOPS per milliwatt that we thought this industry would deserve. So therefore, we leverage on the research that we made to create our own NPU. And so we are about to launch soon the very first chip from ST with this NPU. So it's too early to speak about it, but if you reinvite me in a few months, I can comment and probably have clients speak about it. And then we keep working on that. Our vision is, and it is something inspired a lot by computing, which is if now we start moving into the next generation of this acceleration, and you move from the traditional ability to do an NPU to something that we call digital in-memory computing, or DIMC, then you get another magnitude of improvement in terms of TOPS per square millimeter. So I will still have something that probably will be about 1 square millimeter, but now actually, definitely, I will be able to provide at 8 bits quantization level something in the range of 5 to 10 tops. Now, what
Wow.
happens when you start doing it is I have something that obviously is inexpensive, because in the silicon industry, if you are very small, you are inexpensive. If you are big, you are expensive. It's the way this industry works, because you pay by the surface, the area, and you can access to another level of capabilities. Then you go into vision transformers, you go into LLMs, you go with things which today are not yet into these devices. So it's coming. It's something, we start having test chips. We start looking at that. We start showing at clients. So the first generation is coming now in a few weeks, and the second generation is starting to arrive as a test chip, and it's really innovative. And we're even working on the third generation, but that's to keep you on your feet. You'll invite me another time to discuss about it.
Well, I hope to see more perhaps at CES, which is, I can't believe, a couple months away.
Yeah,
I'm sure
CES,
there'll
you
be
will see
some.
the first generation available and in demo, absolutely, on the ST booth.
Great. Well, I will be there. Um, so your engineers basically work hand in glove with your clients' engineers when building AI for the edge. What are some of the challenges they face in getting products to market, and how do you help with your tools and software stacks and other capabilities?
Yeah. Interestingly, for many clients, the number one problem is access to data.
Mm,
It's it's and it's very interesting. It's the problem is not a problem of algorithm, because I think people have a good control of algorithm between the one that are available, the open source, and whatever you do, you have plenty of algorithm. You have very rich model zoo. We have a very very good model zoo ourselves. We have optimization software, and we'll have even more. We have the hardware capability, as I was talking about, or it's coming soon. Um, the number one problem for many of our clients is the ability to train the model on their own data.
mm,
Because it's not always easy. Data logging is complex depending on the situation. If I do, I don't know, trying to use an example, it's a interesting one. If I want to have a lawnmower, that will be able to move into your backyard without destroying anything, cutting your wife's flower, or cutting, I don't know, anything you might have in your backyard, kids' toys or anything. You
mhm,
have to train the model. What's happening is there is simply no data set in the industry that would be taken at the level of a lawnmower. So you have to start making this picture, but you need
mm,
thousands of them. So this is a silly example, but that's an illustration of that. If I want to do predictive maintenance on I don't know, something that would be let's say whatever device, doesn't matter. If I take a pump, coming back to my example, and I want to start to generate all the possible anomalies, clients know how well a pump runs when they work, but reproducing the anomalies is very difficult. So we are working on that. We have a very specific initiative within our division on what we call generative data set. So that the
mm,
idea to generate data set, which are artificial data sets, that will start from the client actual data set, and then we'll build anomalies. So it's all generative AI. It's extremely accurate. It's saving a lot of time. It's actually shortening the development side on some project by a year, because data logging can take up to 1 year for some for some of the project. So if I can shorten this 1 year to days or weeks, that is a big deal, and this is really helping. So it's one major initiative we have, and the other one is on how you manage a model, refresh them, and when the model has been launched for a while, how do I update the model with new insights, new capabilities, so that my model becomes even more accurate. So it's a two initiative we have, and the third one is to prepare for these DIMC chips, so the ability to quantize, so moving from 8 bits to 4 bit or 1 bit. When you do this, if I move from 8 bits accuracy to 1 bit, what happens is you basically run 8 times faster. So if I said we can go at 10 tops at 8 bits, that means I can run at 80 tops at 1 bit. And if I can do this, then I again go into another class of models that I can start running. still into my 1 square millimeter. And so it's a three initiative we have. We have quite significant teams, developers and R&D working on that at ST, and it's very promising. And we have a number of things that will come to market in 2025 on this subject.
Very exciting. Big engineering challenges, but even bigger opportunities. Thanks so much for sharing just a peek at the vision and the opportunity there. What are you looking forward to in the run up to year end? Heads down, finishing the year. Do you have any travel, any meetings, events coming up worth calling out?
Well, a lot of what I do is driven by our clients. Speaking with our clients on their project, it's what excites me because I love discussing the art of possible
Mm.
on how AI can transform everyday's life and product. I do learn a lot when I speak with these clients. People think that we come to teach, but actually we come to learn, and then that's very useful. So that's what we do, and so in some way, I became an AGI evangelist, but I love it, and it's if anyone listening to that wants to have either myself or one of my colleagues come and chat, we'd love to do it. It's
Well, love the enthusiasm. I've learned a lot so much in this short session. Thanks for your time and the insights. And thanks everyone for listening, watching, and sharing as always. Thanks, Marc.
Thank you, Ivan.
Take care.